morning, grade 9s, and happy greetings to each and every one of you today. Welcome to the WorksheetCloud grade 9 Natural Sciences lesson. If you have a question during the lesson, send an email with your question to grade9@worksheetcloud.com. I am out of my element that you could join me today. I am Mrs. Ernston, the WorksheetCloud grade 9 Natural Sciences teacher. Remember to take notes as we discuss things in our online class. So if you need to go and get paper and pens and things, please rush off now and get yourselves ready. I'll wait for you. So in today's lesson, I would like to do a 3-2-1 bridge activity. What that means is at the beginning of the lesson, I would like you to do a prior understanding of what you know about atomic structure. So I want you to think what you've done in grade 8 or grade 7, maybe grade 6, all about atoms and the atomic structure. And I want you to write down any 3 thoughts or words that you have, any 2 questions that you may have, and then an analogy. So an analogy is something that we can compare an atomic structure to. And then what we're going to do at the end of the lesson, we are going to have a look at any thoughts, questions, and analogies you may have developed through the lesson, and we will bridge these activities together. So grab your pen and paper, pause the video, and write down any thoughts or 3 thoughts or words, 2 questions, and 1 analogy that you have. As a revision of the periodic table, I would like to go over some terminology with you. And the first is the use of the word groups and the use of the word periods in the periodic table. So there are 2 special words to describe the rows and columns of the periodic table. Groups. This refers to the vertical columns of the periodic table. The groups on the periodic table are numbered in such a way that this is group 1, and therefore this is going to be group 18. The periods are the horizontal rows in the periodic table. So these are the rows that go across. So this is going to be the first period at the top of the table, the second, the third. So what is the first element in the third period? So groups refers to the first element, and third period is here. So let's put the periodic table in front of us that's got the names of the elements, and let us see if you can work out what is the first element in the third period. So remember, this is period 1, this is period 2, this is period 3, and that is our first element. So yes, well done, it's sodium. And one more, just to confirm your understanding. Which element is in group 14 and in the second period? So we know that this is 18. So 18, 17, 16, 15, 14. And this is going to be period 1, period 2. Yes, well done. So, chemical properties of elements, they are arranged in such a way that in groups, they show the number of outer electrons in an atom. So often we use Roman numerals. So here we've used 1 and 2, but on some periodic tables you will see we use Roman numeral number 1, number 2. So this is slightly different from what I've just explained to you, because the numbers at the top here, you can add those into the top of your periodic table. These numbers refer to the number of outer electrons in an atom. The elements in the same group have the same, elements in the same group in the periodic table will have similar chemical properties. So that means every element in group 1 has got the same number of outer electrons, and therefore they are similar. They have similar chemical properties, and they undergo similar chemical reactions in the same way. For example, if we go to group 7, the halogens, they have the same number of outer electrons in their atom, and when they undergo chemical reactions, they behave in the same way. So just as a recap, they have the same number of outer electrons, so they will chemically react and bond in a similar way. So just jot that down for now. The groups have the same number of outer electrons, and when we have a look at the electron structure just now, it will make sense to you. So atoms are the smallest parts of an element. So hopefully in grade 8, you did atomic structure. If you didn't, it's not a problem. We'll catch you up today. So this is just a schematic representation of what an atom looks like. So often in the center here of an atom, we have the nucleus, and that is going to contain protons, which are represented here in green, and neutrons that are represented in blue. So neutrons carry a relative charge of +1. So protons carry a charge of +1, and you can remember that by P, protons are positive. Neutrons carry a neutral charge. So we find protons and neutrons in the nucleus of an atom. Then, surrounding the atom, we find electrons. So the electrons are found at large distances from the nucleus. So the electrons actually create a cloud around the nucleus. Electrons carry a charge of -1. So electrons are negatively charged. If we have a look at the generalized atomic structure, we have the nucleus in the middle, and then we have shells that go around the outside. So these shells is where we find the cloud of electrons. So each electron shell can accommodate a fixed number of electrons. So for example, this first shell here, it can only hold 2 electrons. The second shell can hold 8 electrons. And the third shell can hold 18 electrons. So we refer to this as the electronic configuration. So what that is what is the arrangement of electrons into shells for an atom. So electrons will always occupy the shells that are closest to the nucleus first. So when we start drawing atoms, we start with the nucleus, and then we put in the first shell, and we make sure that we put electrons into the first shell, remembering that we can only put a maximum of 2 electrons. And then we'll draw the next shell, and we'll fill it with the correct number of electrons, remembering that the second shell can only take a maximum of 8 electrons. So when a shell becomes full, the electrons will fill the next shell. And here is an example. So here we have the nucleus in the middle. So here is our first shell, and you will notice it's got 2 electrons. Here is our second shell, and that's got 1, 2, 3, 4, 5, 6, 7, 8 electrons. And then here is our third shell, and if you go around, you will see that it has 18 electrons. So let us look at the atomic structure of the first 3 elements. So here's the atomic structure of hydrogen. Here we have our nucleus with our proton, and around it we have our 1 electron in the first shell. Helium is the second element on the periodic table. So here's our nucleus, and we have 2 protons, and we have 2 neutrons. And then we have our outer shell, it's got our 2 electrons. Our third element in the periodic table is lithium. So here we have our nucleus, and we have 1, 2, 3 protons. Wow, this is interesting. But it has 1, 2, 3, 4 neutrons. So I need you to stay tuned so you can work out, why does lithium have 4 neutrons? And then lithium has got 1 shell that has got 2 electrons. So remember that now fills the first shell, because the first shell can only take 2 electrons. So you'll draw a third shell, but we know that a stable atom of lithium has got 3 electrons. So in the outer shell, we put a third electron. This is just a table that you can refer to if needed. It's got all the elements, and then it has got the atomic number of the first 20 elements. And then it shows you the first shell, the second shell, and the third shell. So this shows you the electron configuration. So hydrogen is going to have 1 proton in its nucleus and 1 electron in its first shell. Helium is going to have 2 protons in its nucleus and 2 electrons in the first shell. Lithium is going to have 3 protons in its nucleus, 2 electrons in the first shell, and 1 electron in the second shell. And I want you to have a look at this diagram, and as you go through it, can you see the pattern? So let's have a look at the electron configuration and remind ourselves what it is again, because this is quite a tricky concept to understand. So the arrangement of electrons into shells for an atom. So for example, let us have a look at carbon. So on the periodic table, here we find carbon. Okay, it's in period 2, sorry, okay, and it is in group 14. So the carbon configuration is 2.4. Okay, so here we have the nucleus of carbon. So in the first shell, we're going to have 2 electrons because of that 2. And in the next shell, we're going to have 4 electrons. 1, 2, 3, 4. Now, if we have a look at carbon, we find carbon in the second period. Now, how does that link up with the number of shells that we have? So it's found in the second period, therefore it has 2 shells. So the electron configuration and position in the periodic table. So the number of notations in the electronic configuration will show the number of shells. So what we mean by the number of notations is carbon has 2 and 4. So there are 2 notations, which means carbon must have 2 shells, which also means carbon is in period 2. Then the last notation, there, 4, that shows the number of outer electrons the atom has, and that will show us what grouping it's in. So there, that should be the number of electrons in the outer shell, 4. So we go 1, 2, 3, 4. Let's have a look here. So this diagram below shows an example of one of the tiles on the periodic table. Can you identify the element it represents? So we can see there's a capital C. What element is represented with capital C? And then looking at this tile, are you able to work out how many protons does it have in its atoms? So let's have a look here. So capital C tells us that the element's name is carbon. Now from our previous lessons you have learned that often the elemental name is derived from a Greek or Latin word for the element, or it could be the name of a substance that contains that element. What does the C mean? C is the symbol. It's a shorthand version that we use to abbreviate the name for the element. Can you remember the rules about symbols and elements and the naming of elements? The number at the top generally denotes the atomic number, and this is a very important part of today's lesson. The atomic number, this is the number of protons in the nucleus of the atom. And then the number at the bottom of the tile is the atomic mass, and that is basically the average mass of the atoms in an element. So, how can we use the periodic table to determine the number of neutrons in an atom? Right, so let's take the periodic table here and let's use chlorine as an example. Okay, so if we make this tile bigger, here we've got chlorine. Okay, so if we have a look at the electron configuration for chlorine, it's 2.8.7. Okay, so there is 1, 2, 3 notations. So that means that chlorine should have 3 shells. It should also mean that we will find chlorine in period 3, which we do. Okay, 7, the last number, the last notation, tells us the number of electrons in the outer shell. And it also refers to the group that we find it in, group 7. So, just as a recap, here is an example of the electron configuration of chlorine. The period, okay, the red numbers at the bottom here, 1, 2, 3, show the number of notations. Okay, so there are 3 numbers. So that shows that a chlorine atom has 3 shells of electrons. So 3 shells surrounding the nucleus. The group, which is the green box, highlights the notation, which is 7, and that shows us that a chlorine atom has 7 outer electrons. Wow, that's a lot to remember. It's going to take you some time to go through it, so if you need to rewatch this video, please do. And if you have any questions, remember to email grade9@worksheetcloud.com. So to check your understanding, what I would like you to do now is to draw a diagram of the following atoms. I would like you to draw the diagram of nitrogen, oxygen, and neon. And to prevent you having to try and find a periodic table, I have put a little tile here of what nitrogen, the information nitrogen would give you on the periodic table. And I want to see if you are able to draw a nitrogen atom based from this tile. If you do need to refer back to the periodic table, that's not a problem. You can just go back in the video until you see the screen of the periodic table that we used at the beginning of the lesson. So I will wait for you to finish this activity. So if you can just press pause and do the diagrams of the following 3 atoms so long. So if we have a look at nitrogen. Nitrogen, the atomic number is 7. So that means there are 7 protons in the nucleus. So here's your nucleus, and we represent the protons, which are the positive charge. So that's 1, 2, 3, 4, 5, 6, 7. Okay. We'll also find nitrogen is going to be in period 2. And because of that, we know that it has got 2 shells. And then we also know that we'll find it in group 7. So that means, in group 1, 2, 3, 4, 5, because there are 5 electrons in the outer shell. So we're going to draw the nitrogen atom with 7 electrons. So remember, there are 2 shells because we find it in period 2. In shell 1, it can only take a maximum of 2 electrons. So there's an electron and there's an electron. But we know that it is in period 2, so we draw another shell. And we also know that it is in group 5. So in the outer shell, we need to have 1, 2, 3, 4, 5 electrons. So in total, this atom has got 7 electrons. So just as a recap, this is how we can mark your atom. So the fact that there are 2 shells, the fact that in your nucleus you have 7 protons, the fact that in your nucleus you have 7 neutrons, and the fact that you have 7 electrons, and that your first shell has got 2 electrons. Let's have a look at oxygen. So oxygen, atomic number is 8. So we know that means that in the nucleus there needs to be 8 protons. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then we know that we find oxygen in period 2. So that's why there are 2 electron shells. And because there are 8 protons, we start filling the shells from those closest to the nucleus. So the first shell, you're going to put 2 electrons. You can only take a maximum of 2. The second shell, you're going to put 1, 2, 3, 4, 5, 6 electrons, and you will also be able to work out on the periodic table to find that in group 6. Another thing to always remember is when you do these diagrams in a test or in an exam, please will you always give the diagram a heading. So this would be a diagram showing the nuclear composition and electron configuration of an atom of oxygen. Make that heading as explanatory as possible, and then also remember to keep your work as neat as possible and labeled correctly. If we have a look now at neon, okay, we see that neon's atomic number is 10. Okay, so we know that it's got to have 10 protons in its nucleus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We also know that it needs to have 10 electrons in total. But the first shell has 2 electrons. So that means the outer shell is going to have 1, 2, 3, 4, 5, 6, 7, 8. So we can see that the outer shell is also full of electrons. So remember that your diagram needs to be neat, it needs to be labeled, and it needs to have a heading. This is a really tricky activity. So if you've got a handle on things and you understand it, give this a shot. If you're feeling a little bit shaky, this is really tricky. So here, I want you to draw an atom of potassium and an atom of calcium. So I'll wait for you if you just pause the screen and see if you are able to draw those atoms based on the information given in these tiles and on the periodic table. So let's see how you did. Here is a drawing of an atom of calcium. Okay, so you're going to find there's 20 protons and neutrons in the nucleus, and there's 20 electrons. You will also notice that we will find calcium in period 1, 2, 3, 4 on the periodic table because it's got 4 shells. And if we go around the outside, we can see that there's 1, 2 electrons in the outer shell, which means we'll find calcium in group 2. Now let's have a look at potassium. And here I want to link this up with our question about lithium at the beginning of the lesson. So potassium, the atomic number is 19. Okay, so how can we use the periodic table to determine the number of neutrons in an atom? So you will notice up until now, I haven't really mentioned neutrons. But this is important for when we'll be looking at isotopes later on in our lessons. So if we have a look at potassium, it is going to have 19 protons in the atom. But it's going to have 20 neutrons. So why is this? Okay, what you've got to do here is you've got to have a look at the mass number. Okay, so we round off the mass number, which is 39.098. We round the mass number off to 39. Okay, because that mass number is the number of protons and neutrons in an atom. So we say 39, and now we minus the atomic number, because that's just the number of protons. So 39 minus 19 gives us 20. And that is how come there are 20 neutrons in potassium. So if you go back now, see now if you can work out the atomic structure for lithium. So when we are dealing with a neutral potassium atom, so I'm not looking at isotopes yet, a neutral potassium atom, the number of protons is 19, okay? That equals the number of electrons, which is also 19. And to calculate the neutrons, we take the atomic mass number, which is the number of protons and neutrons, and we minus the atomic number, which is the number of protons, and that will give us the number of neutrons only. So if we have a look at potassium as well, we will find that it is going to be in period 4, because there's 1, 2, 3, 4 shells. We're also going to find it in group 1, because I can see there is 1 electron in the outer shell. And if we have a look at the electronic configuration here, there's 1, 2, 3, 4 numbers. So 4 numbers means 4 shells. It refers to the fact that we found this element in period 4. The first shell can only take a maximum of 2 electrons. So in our first shell, there is 2 electrons. The second shell can take 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. The next shell can take 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Then we draw our last shell, and we know that it is in group 1, and it can have 1 electron in its outer shell. I hope you understand that a little bit better. Again, if not, go back and rewatch the video, or please send your questions through. Let's practice another example just to see if we understand how to do it. So again, how can we use the periodic table to determine the number of neutrons in an atom? Okay, the equation that we're going to use is we're going to take the atomic mass, okay, because the atomic mass is the number of protons and neutrons. And we're going to minus the atomic number, because the atomic number is just the number of protons. And that will then give us the number of neutrons. So here is our tile for an element known as molybdenum. The chemical symbol is capital M lowercase o. The atomic number is 42, so that means in the nucleus of this atom we have 42 protons. The atomic mass number is 95.94. So what we'll do is we'll round that off to 96. So we say the atomic number is 96 minus the mass number that's 42. That is going to give us 54 neutrons. So we need to put 54 neutrons in the nucleus of this atom. Here is a nice little diagram that might help you to understand the concepts a little bit better. So what I have done is we have taken out the transition metals, okay? And we are only looking at the first 20 elements because that's all you need to know. So hydrogen, atomic number is 1. We find it in period 1, group 1. So period 1 means it's got 1 shell. Group 1 means it's got 1 electron. Now we move to helium. Helium has got, we find it in group 1. Period 1, and that's why it has 1 shell. But we also find it in group 0. 0 means that we have completely filled the outer electron shell with 2 electrons. It can't hold anymore, so that's why we say that it has got a maximum number of 2 electrons, and we put it into group 2, with the noble gases. Let's have a look at helium. Helium we find in group 1. That means there's going to be 1 electron in the outer shell. We find it in period 2, therefore it's got 2 shells. So everything in this period should have 2 shells. Beryllium, 2 shells. Boron, 2 shells. Carbon, 2 shells. Everything in group 3, period 3, should have 3 shells. 1, 2, 3. 1, 2, 3. Go here to the end. 1, 2, 3. Then if we have a look at the groups that we find them in, that is the number of electrons in the outer shell. So in the second group here, they've all got 2 electrons in the outer shell. 2 electrons. 2 electrons. This is also just another little table that summarizes the number of electrons with the electronic configuration as we move through the elements, and you will find a list of the first 20 elements with the number of electrons and electron configuration in the WorksheetCloud worksheet that's been uploaded with today's lesson. So to end off the lesson, I want you to build a bridge. I want you to look at your 3 thoughts or words, your 2 questions and your analogy that you had before the lesson. And I now want you to build a bridge, and I want you to add any new thoughts and ideas or understanding that you have. And I want you to connect your prior 3 words with your 3 words that you've written down after today's lesson. So write down any thoughts or words you have. If you have any questions, please remember to send us an email and we'll answer them as soon as we can. And then write down your analogies. And what I'd really love you to do is when you are able to get back to school and speak to your teacher, I want you to show your teacher the analogies that you were able to bring about your prior learning to the atomic structure and then after today's lesson. So just to build that final bridge on atomic structure, what I want you to do is I want you to write, and it could be more than 1 sentence. I used to think this, ... and now I think this, ... And the ... refers to atomic structure. So before the lesson, what were your thoughts on atomic structure? But after listening to this lesson, what are any new thoughts that you have? So grade 9s, thanks for watching today's lesson. It's been brought to you by WorksheetCloud, and I hope you have a wonderful Wednesday.